So it is my privilege to introduce Richard Heinberg, who is a senior fellow at the Post-Carbon Institute. And they're dedicated to building more resilient, sustainable, and equitable communities. Many of you probably know Richard well from his over 10, I believe 12 books that he's written, which include The Party's Over, The End of Growth, and Snake Oil. So you might get a sense of what we will be hearing today, and it is with sincere appreciation that we have Richard here with us today to talk about the reality that we're facing and the opportunities that we have together in terms of turning that challenge into opportunities. So it's my honor to introduce Richard Heinberg.
Well, it's my honor to be here with you all who are doing so much, and I think we just heard some of that, but certainly not all. Oops, let me get my stopwatch going again here. There we go. Now we got that. We got this. And I'd like to thank Joey Miller and David Blittersdorf for getting me here. And I'd like to start by talking about what else got me here. I'm not an energy engineer. I actually started out as a violinist. But early in my musical career, I read a couple of books, Limits to Growth and Small is Beautiful. And I realized there was a lot more going on in the world than just, making beautiful sounds, hopefully beautiful. And so I gradually transitioned my life work into that of being a writer. And as a writer, I had the luck of being able to focus my attention on subjects that I thought were most important. And what the question I wanted to answer was, why is this all happening? Why are we living in an industrial society that is undermining its own long-term viability? I mean, this seems really crazy on the face of it. The way we are living is so different from how people in any previous era have lived. The scale of population, of resource consumption, and of habitat destruction is just off the charts. So I looked into all sorts of explanations, looking into economic history and political history, even mythology, which was actually the subject of my first book back in the 1980s. It wasn't until the 1990s that I realized that energy is the key. If you don't understand energy, you can't possibly understand how societies work, how societies change, even how the human body works or how ecosystems work. It has to start with an understanding of thermodynamics and energy systems. Once I finally got that through my thick little skull, I realized that we are living in such an extraordinary moment of time because our energy system is so different from anything that's existed previously. We used renewable energy for thousands of years, for as long as we've been human and before we were human, because that's all there was. We used it in the form of firewood, of course, but also food crops were a source of energy. And we exerted energy into our environments to get what we needed by way of muscle power, human muscle and animal muscle, and even other people's human muscles by way of a horrible, horrific institution called slavery. Well, all of that changed when we figured out how to harness and extract fossil fuels. Why was this so different? Well, Forgive me if you've seen a presentation of mine before, because I always show this slide and always make this point, but I'm going to do it again. You've, I'm sure, had the experience sometime in your life of running out of gas and having to push your car off to the side of the road. Okay, even if it's only 10 feet, that's a lot of work, right? Now imagine pushing your car 20 or 30 miles. How much work is that? Well, probably somewhere on the order of 6 or 8 weeks of hard labor. We're getting that done for us currently by gasoline that's costing us less than $2.50, in many parts of the country less than $2. So $2 for the energy equivalent of 6 or 8 weeks of hard labor. That is cheap energy. It's concentrated energy, it's portable energy, and it's what's enabled us, for one thing, to replace human slaves with energy slaves. Each of us Americans is traipsing around with somewhere between 150 and 300 fossil-fueled energy slaves picking up after us and pushing us around in our cars and vacuuming our carpets for us and all the rest of it. But here we are in the beginning of the 21st century, only a couple of centuries into the fossil fuel age, realizing that it can't go on for a couple of good reasons, one of which is that burning fossil fuels is changing the climate. We're doing history's greatest chemistry experiment by changing the chemistry of Earth's atmosphere. And it's very clear that this is going to have catastrophic effects, and not centuries from now, but we're already beginning to see it. Meanwhile, fossil fuels themselves are finite, non-renewable resources. So by definition, we actually started running out when we got the very first barrel of oil and ton of coal out of the ground. This little chart is helpful in understanding the situation. We're not about to run out of oil, coal, or natural gas, but we've extracted them using the low-hanging fruit principle. We started at the top of this pyramid of resource quality with conventional resources, conventional oil and natural gas, and high-quality anthracite and bituminous coal. And we're digging our way down. And with each new increment, we're forced to extract resources of lower quality that have higher costs of extraction and higher environmental risks. And at some point, we get to the stage where it actually costs us as much energy to extract a barrel of oil, let's say, as the oil will give us when we burn it. At that point, it doesn't matter that there's still enormous amounts of oil left in the ground, which there will be. It might be useful as a lubricant or something like that, but it's no longer an energy source. We're moving as rapidly as we can in that direction. We started out with conventional oil in the mid-19th century, and this is what the oil industry looks like today. The costs of extraction have skyrocketed in recent years. I'll get back to that point in a moment. The growth that we've seen in world oil supplies over the past few years has been primarily from unconventional oil here in the United States in the form of what's called tight oil, light tight oil. It's produced by hydrofracturing and horizontal drilling. This is a very low-grade resource in the sense that it's produced from rocks with very low permeability, and that's why they have to be fractured in order to move the oil out. These kinds of low permeability, often shale rocks, see very high decline rates. In other words, if you drill, this is for shale gas, which has a similar profile, drill a well in January, and by December of the same year, production from that well has fallen by around 70%. And that's why the industry has to drill and drill and drill. And something like 80,000, that's 80, not 8, 80,000 wells, shale gas and tight oil wells have been drilled in the past 8 years here in the US. I mentioned higher investments. the rate of investment in the oil industry was increasing until very recently, about 10.9% per year. And that investment was required largely to make up for declines in existing production. But what happened with the shale boom was that there was the incentive for smaller operators. We're not talking about Chevron and ExxonMobil and Shell. We're talking about mostly smaller companies that had the incentive to move in, lease as much land for drilling as possible, borrow money, which they could at very low interest rates after 2008, get as much money as they could from investors who were looking for the next big thing, and then drill as much of that land as quickly as they could. And so this resulted in very high rates of production, and US oil production basically doubled from the beginning of the shale boom until just recently. But the result was overproduction, and with the help of the Saudis now, oil prices have fallen precipitously down to the $40 range. And at that price, everyone in the fracking fields is losing money, whether it's oil or natural gas. Virtually every producer is losing money, which I think is a good thing, frankly. But what it does, of course, is put us in a bind as a nation, because everyone is expecting more of the same. Even if oil prices pick back up, or natural gas prices, the nature of the resource is that we've probably already seen peak production or close to it. Even if drilling had not declined, our in-house research suggests that both shale gas and tight oil production would have peaked and started to decline before 2020. And in the shale gas world, all of the plays are in decline except the Marcellus in Pennsylvania. The earlier plays like the Barnett and the Haynesville have already declined to about half of their former production. The Bakken in North Dakota is in decline. U.S. oil production altogether has declined about 500,000 barrels a day in the last few months. So we're looking at an energy system that no longer responds to supply and demand or ordinary economic theory in a rational way. It doesn't respond to rational planning. Okay, so these two things are going on: climate change and the depletion of the energy sources that make our world work currently. So the renewable energy transition is absolutely necessary. I mean, seeing these two forces on the horizon, there's no other realistic conclusion. People say, well, we need nuclear power. No, come on, the nuclear industry is in its death throes globally. Most countries are seeing nuclear power plants being retired, partly because of the greater perception of risk as a result of the ongoing Fukushima disaster, and partly because these things are just too expensive. They always require enormous government subsidies, and they never come in on budget and on time. Renewable energy is quite different in that regard. It's growing rapidly, and there's an enormous potential for increase. So most of our work over the past few years at Post Carbon Institute has been about tracking the depletion of fossil fuels, so that we have a more realistic understanding of where that energy regime is going. But more recently, we've undertaken a project called Our Renewable Future. And in this, I've been working with one of our fellows, David Fridley, who's staff scientist in the energy analysis program at Lawrence Berkeley Labs. And so we've been looking both at the potential for renewable energy supply, but also at what's actually going to be entailed in the transition to a renewable energy future in terms of how we use energy. Not too many other folks have looked at that really seriously up to this point. So, okay, first of all, we all know that solar and wind have intermittency issues. In the early stages, that's not a big problem. As time goes on, we are going to have to find ways of dealing with that intermittency, either through storage or capacity redundancy or completely rethinking the grid. So it's going to be, there are difficulties in this transition. It's not going to be complete smooth sailing, and the market isn't going to do it for us, regardless of how much solar and wind prices are falling. Then to this point of how our energy consumption is going to change, we have built our current energy consuming, or energy using is a better term, infrastructure around the strong suits of our current energy sources. And we've added new energy sources based on opportunity. What we're looking at now is a shift in energy sources that will be driven largely not by market forces, but by policy. This is something that's quite different from almost anything that's happened before in our history, with the possible exception of the ending of slavery as an energy regime. That was also a policy change, and it was a bit controversial at the time. Here's another thing that we should all be aware of, and it's already been mentioned today. Electricity is only about 21% of our national final energy use. So how we use energy in other ways is going to be really important if we want to get to 90 or 100% of all of our energy use from renewable sources. So what David and I have done is divide all of these processes of transition into 3 levels, and starting with the easy stuff. Now, I'm not saying phase 1, phase 2, phase 3, because that would imply first we do this, then we do this, and then we do that. We're actually going to have to start with all of this stuff at the same time. But it's important to know where the low-hanging fruit are so that we can really dig our teeth in there. And the lowest of the low-hanging fruit is coal. Just legislate it out of existence. Replace it with solar and wind power. This we can do relatively quickly, and it will give us the greatest bang for the buck in terms of reducing carbon emissions. Then, as many of you have been discussing, air source heat pumps, great idea for heating indoor spaces. This technology wasn't widely available only a few years ago. Today it is, and for folks who are heating their houses with oil, especially, or natural gas, here is a way. It's much more efficient than the traditional resistance electric heaters. Here is a way we can electrify portions of our energy use so that we can then power them with renewables. Renewables generally produce electricity. So we need to electrify as much as we can, and here's a way to do it. In the transport sector, we now have electric cars in larger numbers, but they're still pretty small numbers in the overall scheme of things. And cars are pretty energy inefficient altogether, if you really think about it. I mean, having a couple of ton vehicle to move usually one person around, it's pretty crazy. So doing as much as we can right now to promote walking and bicycling and existing public transit is a lot cheaper than replacing our automobile infrastructure. So that's in phase 1. That's something we can do right now. And when we're talking about electrifying things, we're really talking about stuff that we maybe haven't thought of or take for granted. Those of us who cook with natural gas, that natural gas that's a fossil fuel. We know how to cook with electricity. We can also cook with sunlight, solar cookers during the summer. My household, we use them all the time. And our food system. Our food system is a big user of fossil fuel energy, so we need to begin to think about how to transition our food system, making it more organic, reducing the chemical inputs, which include nitrogen fertilizer made out of natural gas mostly, and pesticides and herbicides made from fossil fuels, and reduce the food miles that are embodied energy, embodied into our food. Okay, that's the easy stuff, and if we do all of that, if we can at least get started on transportation and go a long way on buildings and get rid of coal, we can get rid of maybe 40% of our carbon emissions in a relatively short amount of time, maybe even in 10 years. Okay, so now let's get to the next level of stuff. Here's natural gas. Well, this isn't a picture of natural gas, but we're going to need a lot more of these to deal with natural gas because, see, the reason it's in a harder category is that we are using natural gas for peaking plants, to power peaking plants, to make up for the intermittency of solar and wind. So when we get to the stage of removing natural gas from the electricity mix, we're going to have to start looking at things like storage. Batteries aren't the most efficient way of storage. Pumping water uphill into reservoirs is much more efficient, but not every place has the geography that will enable us to do that. Hydrogen storage is another possibility. There are no easy or perfect answers here. Storage is expensive. So we're going to have to design our system in such a way as to minimize the need for storage. And part of that will mean using energy at the times it's available, rather than just assuming it's available on a 24/7 basis. Now that will be not just a household decision, but that's something that will be an industry opportunity as well as challenge that will probably be led through energy pricing. Then building out lots more mass transit. You know, we need to get rid of automobiles and highways, which are made out of, guess what, asphalt and concrete. I'll get to concrete in a moment. And then how about global trade? Moving products around the world on ships that burn oil. Well, we can put sails on those ships, and that will make them much more energy efficient, but they're not going to run entirely on sail power unless we reduce the scale of global transport very, very significantly. So here we're starting to see the need not just to replace one set of energy sources with another set of energy sources, but actually to change the way we're using energy and how much energy we're using. Then with buildings, getting to a passive house standard for all new construction and for energy retrofits across the nation, across the board. It certainly can be done, and those higher level energy regulations are already being adopted in Europe. So now we get to the really hard stuff, maybe the last 20%, roughly. Construction of large buildings uses a lot of concrete, which concrete, the main ingredient is cement, and the way we make cement involves high heat process, about 1500 degrees Celsius, lots of fossil fuels, and the chemical process of making this cement also releases a lot of CO2. Cement is the most carbon-intensive industry. Cement making is the most carbon-intensive industry on the planet. Well, we could supply the energy for this process theoretically with electricity or concentrated solar or hydrogen, but it would be much more expensive cement. So what we're really talking about is changing the construction industry pretty substantially, going to much less concrete and steel, more local natural materials, recycled materials, building on the human scale. Might there be some advantages to that? A lot of manufacturing is already electrified. But the stuff that we use in manufacturing, the raw materials, are extracted using fossil fuels. And this is category 3 stuff also, because these machines you see here, this mining equipment, theoretically it would be possible to run these machines on solar or wind power, not batteries though. Batteries don't have the sufficient energy density. You have to have cables running to the machines. It's theoretically possible, but again, this is going to be difficult, and probably the scale of these industries would not grow, probably shrink under this kind of regime. And then there's the use of fossil fuels in materials themselves, plastics, paints, lubricants, and so on. Some of these have good renewable substitutes. I mean, I'm sure you've all used plastic forks and spoons made out of cornstarch, but high-grade industrial plastics used in the electronics industry and other industries, it's going to be much more difficult to make bioplastics that have the needed characteristics, especially difficult with lubricants. So manufacturing itself is probably going to shift to a smaller scale, using more, again, recycled natural materials, reusing, repairing. It's probably eventually going to mean the end of consumerism as an economic model. This was an economic model we developed in the 20th century as a result of fossil fuels. We had so much cheap, abundant energy, we could make stuff faster than people would ordinarily buy and use things. And that overproduction ultimately led to an economic problem known as the Great Depression. We solved that with advertising and consumer credit and the consumer economy, so that consumption became 70% of the economy, and if something went wrong, like 9/11, the solution was to go shopping, right? That's a form of economy that probably cannot survive the energy transition, and I think we'll probably be better off in any case. The whole electronics and communication industry is going to face some serious challenges here. The folks I know who have done life cycle analysis studies of things like cell phones and cell phone towers and computers and servers and so on report that it's going to be very difficult to replace the kinds of materials and energy used in these production processes with entirely solar-based or renewable-based energy and materials. So again, the solution here for this industry is going to be, getting a smartphone for your 18th birthday and using it for a few years until it needs to be recycled and remanufactured. Forget, buying a new smartphone every 18 months. Then also in category 3, very, very clearly in category 3 is aviation. There are some proposals on the table for flying planes with sophisticated biofuels or cryogenic hydrogen. We don't see much likelihood of this happening on a large scale. We might be able to preserve some vestiges of an aviation industry with these alternative fuels, but they're going to be much more expensive fuels, and in the case of hydrogen would require a complete redesign of the entire fleet of vehicles. So aviation may end up being a mostly 20th century phenomenon. We're going to have to really concentrate on the transport modes that are most easily electrified and that are the most energy efficient. And rail really comes out pretty well by both of those criteria. So we should be building electric rail all over the place. That should be our #1 priority. Forget building one more road anywhere. Don't need it. then back to agriculture. By this time, if we do this really well, we could actually, with organic and soil-building agriculture, we could sequester an enormous amount of carbon. You know, over the past couple of hundred years, through our industrial agriculture and grazing processes, we have lost about 136 gigatons of carbon into the atmosphere. Now, where are we now? At 400 parts per million CO2 in the atmosphere. Where do we want to be? Well, at least down to 350 parts. And how much carbon is that? Well, it's about 106 gigatons. So we've lost more than that from the soil in the last couple of hundred years. So that tells us that if we start rebuilding soil, rebuilding ecosystems, restoring forests, we could actually pull as much carbon out of the atmosphere as we put into it. Now, obviously, that's not going to happen overnight. It's going to require the complete reform of farming as we know it, re-education of millions of farmers around the world, redesign of food systems and all the rest. But at the end of the day, what we get is healthier food, healthier communities, and an atmosphere that more closely reflects what our species evolved to live in. Okay, so those are the three levels. Many people ask, well, can renewable energy enable us to continue living the way we are today? Well, think of it this way. If you look at the data from the Global Footprint Network, the ecological footprint, it's telling us that if everyone in the world were to live the way Americans do, we would need an additional 3 Earths. Right? So asking if renewable energy can enable Americans to live the way they're currently doing is basically asking if renewable energy can enable Americans to continue living unsustainably. Maybe temporarily, but why bother? We need to reduce the flow through of materials and energy for ecological reasons that are unrelated to climate as well. In fact, reducing energy use is going to be as important in the transition as building renewable energy capacity. It's maybe not as exciting for many of us to think about, but those of you who are involved in energy efficiency and energy conservation really deserve credit, because you're involved in efforts that are as important as anything else in the climate fight. It's great that Vermont has a comprehensive energy plan, and I was excited to see that it calls for a reduction in total energy use. Maybe more than that ultimately will be required, but at least it's getting started in the right direction. It's acknowledging the need for conservation. As I said, conservation is not always the sexiest subject, but as we educate our neighbors and friends, families, it's important that we underscore to them that we're living in an extraordinary moment of time where we have energy available to us on a scale that is simply not going to be available in the future. Our renewable future is going to entail less total energy. That energy will be less controllable than fossil fuels were in the past. We're going to have to use energy at times and in ways appropriate to the sources we have. We will be less mobile. That means we need to relocalize our economies. It's not going to be a matter of unplugging the coal power plant, plugging in the solar panel, and continuing to live the way we have. This is a civilization reboot. Nobody knows exactly what this is going to look like at the end of the day, but if you look back at past energy transitions in human history, they entailed overwhelming transformations of economies and political systems. something like that is no doubt in store, but what a time to be alive. We have the opportunity not just to redesign our energy infrastructure, but ultimately our economy and our political system are going to have to change as well. And we should be involved in all of those efforts. Energy equity is going to be extremely important in all of this, because if only rich people can afford renewable energy, guess what kind of world we're going to end up with? It's going to be a world that basically nobody wants to live in. The benefits of the energy transition ultimately are extraordinary. We could have not just an acceptable quality of life, but a better quality of life. The global happiness movement is looking at getting beyond GDP as a measure of human satisfaction and well-being, and looking at the factors that actually make people happy, their sense of connection with the people around them and their communities, the transparency of their governmental institutions, and so on. These are the things that make people satisfied, much more so than having a fast, powerful car. There will be costs. This is all going to be expensive. We're going to have to redirect public investment toward the energy transition in every way we can. Not just to building out solar and wind capacity, but also all of the transformations in agriculture, transportation, and manufacturing that we were talking about earlier. Now, here's an interesting question. Can Vermont be a model for the nation and the world?
Yes.
The fact that Vermont has an energy plan, I think, is extraordinary, because without a plan, none of this is going to really happen, at least not in a very effective or rapid way. We need a coordinated plan, and a plan that takes into account not only energy supply, but energy usage in all of these sectors. So Vermont's plan is a great start, and it needs to be replicated in every state of the union, and it has to be granular enough so that every community is able to implement that plan in a way that's sensible at the local level. I hear a lot of discussion here about the possibility of a carbon pollution tax. Good idea. Without a carbon tax, it's going to be very difficult to finance these kinds of changes, and the kinds of investments that will be required. And we have to push this transition much faster than the market would do by itself. Again, if we just wait for solar and wind to get cheaper, or cheap enough to push the transition along, we will have waited far too long. The fact that Vermont is a pretty cold state means that there's a huge opportunity in retrofitting of buildings to save energy. All the rest you see here, you can read for yourselves. There are some challenges too, though. I mean, we have to be honest in our accounting of how we're doing in the energy transition. Like, for example, do you count embodied energy in imported materials and products? Well, that's something that should at least be considered, because embodied energy is really important in all of this. We tend to think only of operational energy that we're using in real time to run our computers and cars and lights and so on. But all of the stuff around us represents energy that was expended in the past in order to produce these manufactured objects and materials. As time goes on, we need to reduce that load of embodied energy, and that means different choices in products and materials. Okay, so I'm about at the end of my remarks, so I'll just note that there's an ethical dimension to all of this. Just as there was back in the 1850s and 1860s when we made an energy transition that ended slavery. You know, we need to free our fossil fuel energy slaves. And it's every bit as important to our future, to our children and grandchildren, as anything we've ever done in our past as a species. Practically the most important thing we've done. So again, the work that you all are doing, I can't praise you enough, because we need, you know, thousands of rooms filled with folks like you doing similar work in states around the country. And I have to tell you, I give a lot of these talks, and I don't see as much going on in most places. There are good folks doing good hard work in every state, but Vermont is special in a lot of ways. And so it's great to see what you all are doing here, and I hope that these remarks will maybe help provide a sense of context and a sense of the long haul that we're all involved with. And this isn't something that's going to be over in a year or 5 years or 10 years. We're going to be in this for the rest of our lives, and it will probably continue after that. This is one of history's great turning points. It's a lot to think about, but where else would you rather be? Thanks very much.
We have a few minutes for some questions for Richard from the audience. So I don't even know if we need a mic. So George, starting here.
Yeah, you said something, and I hear it in almost every conversation on renewable power that I get involved in. And it's something that I think none of us should ever let go by, because it is wrong to permit it to be said. And that is, the sun doesn't always shine and the wind doesn't always blow. And the reason why we shouldn't let that happen is because it is completely irrelevant. The sun always shines when the demand is greatest, and the wind never stops everywhere at once. And if you compare the output of renewable power with the output of those big centralized so-called baseload power plants, you see that they are dinosaurs that have terrible ability to match grid demand. When the Vermont Yankee plant was built, just 20 miles down the river, the Northfield Station was built. It's a pumped storage plant which was taking Vermont Yankee's excess power and didn't know what to do with it at night, and pumped water up to the top of a mountain and ran it down to make up for the power that Vermont Yankee couldn't do during the daytime because it's inflexible. And that pumped storage plant has twice the output. And by the way, it's still going.
That's great. Does anyone have a question or comment based on that, which is great? We'll start back here and then we'll go to Alan. Sir? Yeah.
Sure. 10 years ago, I was real excited. I'm a rare individual. I was real excited because I was hopeful that peak oil would cause such a severe economic disruption around the globe that it would stop us from killing ourselves with climate change. And I'd like to know what your current perspective on that all is.
Yeah, well, we're not going to run out of fossil fuels fast enough to solve the climate problem. It's just a fact. You know, we're going to have to make a deliberate decision to leave the stuff in the ground. That's not to say that peaking of oil production and the decline in resource quality isn't going to cause us some severe economic problems as time goes on. I like to say fossil fuels are too valuable to burn, because we're going to need the remaining fossil fuels not to power our existing way of life, But to fund the process of transition, building all the stuff we're talking about, alternative transportation and manufacturing and all the rest, is going to take energy. And in the early stages, most of that energy is going to have to come from fossil fuels. So we have to start thinking about fossil fuels in terms of triage, finding ways to use them preferentially for projects that will help us make the transition to a renewable energy future, rather than using them for, again, powering our current way of life, or for projects that will dig us even deeper into dependency on fossil fuels.
You just call people. Alan, did you?
So I believe most Vermonters get climate change, at least in a relatively stronger way than most of the country and maybe some of the world.
Speak up, Alan. Speak
but-
up. Or I can give you the mic.
So I believe Vermonters get climate change relatively well. I also believe that climate change is something that most Vermonters, and energy in general, is something that most Vermonters just don't want to think about. I have that experience having 8 years on the Energy Commission, working with the public and local government to back that claim up. I believe that Vermonters also recognize that Vermont, as has been pointed out in various presentations today, cannot solve climate change, right? We can't reduce or absorb enough greenhouse gases to solve the problem. It's absurd to think so. So therefore, the only thing we can do to make meaningful impact on climate change is to, as you alluded, set the example, to be the model, to show others that you can solve the problem while being economically advantageous and improving quality of life. And we have a bill on the floor, H412, that promises to do exactly that. What we don't have is, and I was very excited to find out this morning that Shumlin is in Paris touting Vermont's way on climate change. But what's very much missing from our leaders, not all of them, but what I don't hear enough from our leaders, especially Shumlin, is trumpeting of things like H412 that promise to do exactly that, that promise to enable Vermont to be that model for not just the rest of the United States, but the entire world, to follow in the footsteps of places like British Columbia, who have already done that. How important is that, do you think, to the success? Should we be demanding more from our leaders to take that, what shouldn't be such a political, dangerous step, to speak out on these issues and trumpet what is the only way for Vermont?
Always demand more from your leaders. Because it's difficult for them to do many of these things unless they are pushed by a constituency to take difficult decisions on climate and energy. They're going to inevitably fall back on the opposite push that they're getting from the entrenched industries to shut up about climate and not really do anything. So even if we have good people in office, we have to continue pushing them.
There's a slew of questions back here. Lauren?
One of the best documentaries I have seen is Crude Awakening, which, if you look at the middle of that, tells the history of oil and makes the point that you just made so well about why we need to save oil for when it's most needed. It's such a precious resource, so I really recommend that documentary. Chris Martenson a few years ago talked to us about exponentially increasing phenomenon, including population, and I didn't hear you address that. And also other precious resources which we're going to need for solar and wind manufacturing, and I didn't hear a lot about that. So I'm just concerned about those areas, and I wondered if you could speak
great.
to that.
Thanks for mentioning those things. Population is extraordinarily important because if, in fact, our energy and materials consumption will be constrained in the future, as they inevitably will, That means that if population continues to grow, then per capita consumption is going to have to decline really substantially. If, however, on the other hand, we can get a control on population growth, and over time, through family planning, through the empowerment of women in poor nations and all the rest that's been proven to be effective, if we can actually reduce population, that's going to make all of the problems, ecological and energy problems that we're facing, much, much easier. As for the materials that are important in making renewable energy technologies, same situation as with our remaining fossil fuels. You know, we're going to have to steward those materials very carefully and think strategically about their use. For example, my understanding, I'm open to be corrected on this, is that the global lithium supply would enable us to build batteries for about one generation of electric cars for the entire planet, you know, 1 billion or so automobiles, electric cars. So what do we do, you know, 20 years after that, when all of those electric cars are ready to be replaced? Well, yes, we can recycle things like lithium to a certain extent. There's always inefficiency in recycling, but nevertheless, that suggests that you know, we may need to steward that resource in other ways. And I think that's true of rare earth materials that are used in the powerful magnets in wind turbines and so on. These are materials that need to preferentially be directed to the renewable energy industries rather than elsewhere in the economy.
I'm a great fan of air source heat pumps. They're extremely useful for the design of net zero homes and for space heating in existing homes for portions of them. But the reality is that in Vermont we have some of the oldest housing stock in the country. And the reality is that we are more than likely going to have to burn something in order to heat those homes, at least in the near term. We have existing technology, advanced wood heating, that is a renewable technology. Heat pumps are not a renewable technology, they're an electric technology. And we have the ability to do that now with commercially available technologies that would cut greenhouse gases, save money, and heat our existing building stock. I rarely hear it though. When I go to renewable energy conferences or conferences like this. What's your opinion on biomass for heat?
Yeah, biomass for heat will have to be part of the equation. Probably biomass for electricity generation will have to be part of the mix as well, along with geothermal and hydro. Now, the more we can rely on biomass, geothermal, and hydro for power generation, the more predictable our electricity supply is going to be. But in terms of space heating, the one problem with using biomass is, of course, that even though it's a renewable resource, it's an exhaustible resource. And as we all know, Vermont was basically denuded of trees just about a century ago. And that was a renewable economy in that sense, but it's not one that we would want to return to. The energy economy of biofuels, for example, is very disappointing. So biofuels are probably going to have a very limited application in the renewable energy economy. And where we use biomass for heat or electricity generation, which is also, of course, heat burning, just in a different context, we're going to have to be really honest with ourselves about the energy accounting and about the ecological accounting, so that we're not drawing down the renewable resource or compromising existing ecosystems, forest ecosystems.
I'm just gonna take one more question over here.
Richard, you pointed out that there's a lot of things we're going to have to give up. And one of the things that we've spent the last 150 years doing is moving people off of the farms and into the cities and suburbs into some kind of productive economy. Do you see that continuing, or is that, are we going to have to reverse that, and what do you think the future is going to look like in terms of where we're going to be using labor?
Yeah, good question. I just wrote an article on this for this next State of the World volume. We've just passed the 50% mark globally on urbanization. Half the world's people now live in cities. This is completely unprecedented. Back when we had a renewable global economy, something more like 10% or less of human beings lived in cities. As we move to a new renewable economy, which will be very different from the renewable economy of the 19th century, we will nevertheless, I think, inevitably need to re-ruralize, at least to a certain extent. Why? Because industrial agriculture depends so much on fossil fuels. And the kind of agriculture that we need to replace industrial agriculture is going to be more granular, more small scale, more localized. It's going to require more skill on the part of farmers, more ecological knowledge. And training farmers, farming as a way of life, all of that is going to take on much, much more importance. So when I see organizations of young farmers, idealistic young farmers, like there's one called the Greenhorns, I get really excited because I think this is one of the most visionary occupations that young people can enter into, and they deserve all the encouragement we can give them.
That's great. I just want to ask folks to join me in thanking Richard for his wonderful presentation. Some real and significant and important context. So thank you so much, Richard, and thank you again to All Earth Renewables for making it possible to bring this fantastic and inspiring speaker here. So.